Okay, in this video, we are going to study instantaneous velocity. Like in the previous video, in lecture, we already discussed the example of velocity, average speed, and so on. So now, today we know the about the instantaneous velocity, like that. What is instantaneous velocity? So instantaneous, first let's see the definition. The velocity of an object in motion at a specific point. This point is necessary in time. For example, what does it mean? I just here show one example. This example will clear the instantaneous velocity, that what is instantaneous velocity and what is this specific point. For example, this is the school and this is the our home. So now we are going toward home. So if on walking, not through by car, so at some point, let's suppose at the starting point, my speed is 2 meter per second. After some time, my speed is more fast. Let's suppose 10 meter per second. And after some time, again my speed is let's suppose 3 meter per second. So you will see the speed is different going from school toward your home. So now what is instantaneous velocity or what is instantaneous speed? Also clear these all points. So if I select any one of them, let's suppose this is the first second, this is the 2 second, after 2 second this is the third second. For example, I select this speed, only exact. This is called instantaneous. In instantaneous, we do not select the whole speed, just particular or specific point. Like in second, like in 2 second, this is the specific point, and the speed of this object is 10 meter per second. So this is called instantaneous. So if we add the direction, like toward east, toward south, or toward north, or so this will clear the velocity, or this will show the velocity. So this is called instantaneous velocity. When instantaneous velocity is nothing, just we select the specific point or particular point or that moment or one moment speed. So this is called instantaneous velocity and instantaneous speed. So okay, and next page we are going to study the different types of graph, which is much more useful and used in the motion chapter. One thing is, remember, for the motion chapter or for the motion graph, at the horizontal side usually we select the time. Look at here, we have different types of graph. Like the first one is xt graph, mean distance time graph. Distance time graph give us the speed, displacement delta x. This will gives us velocity. The last one, velocity time graph, or we can write like vt. This one is displacement time graph. We can simply denote it by this. But here is nothing, only one thing. Remember, on the vertical side we select the velocity or displacement or distance, but on the horizontal side we usually or must put the time. Like here, on every graph or every motion graph, there is a time on the horizontal side, and the vertical side there is different thing like distance, displacement, and velocity, acceleration, and so on. So now we are going to next page and study about one example which will clear the velocity, or this is the displacement time graph which gives us velocity. Let's see how. They say graphical representation of velocity or slope of delta x mean displacement time graph gives us velocity. Like how? For example, let's see here. In the first second, the velocity in the first second this object covered the 20 meter, and second it covered 40 meter. This is 20 meter, this is 40 meter, this is 60 meter, and third second this object covered 60 meter. So if we combine this all point, so it will give us the straight line like this. So and also it will make the angle here with the horizontal or base. So this angle is called slope. Whenever we are going to study or discuss the displacement time graph, it gives us the slope, and this gives slope gives us velocity, and slope mean angle. This angle which is made this line with the horizontal side or base side. Okay, how? Let's see here. This is the this is the vertical side, this is the horizontal side. For example, in 1 second the initial point or the initial position of this in 1 second is 20, but the final second or the final position x of f is 60. In how much time? Like let's suppose this is t of I, this is t of f. So let's see, we use the velocity formula or average velocity formula. So let's see, average velocity is equal to delta x divided by delta time. So now this delta x is equal to x of f minus x of I divided by this delta t is equal to tf minus t of I. Now putting the value, x of f is equal to 60, x of I is equal to 20, t of f is equal to 3, and t of I is equal to 1. Now putting the value or add in it separate, so this is equal to 60 minus 20 is 40 meter, and now this is equal to 2 seconds. So it will gives us the velocity or average velocity. 40 divided by 2 is how much? 20 meter per second. So this is the graphical representation of the velocity. Now in next page we are going to study the find the velocity and draw the VT graph. So this is the simple question or example that they ask, find the velocity and draw the VT graph or velocity time graph.